this 6-story building, and we were working on behavioral real-time recommendation engines at a company called Aggregate Knowledge. Myself and my co-founder, a guy named who was at long-term Sun guy named John Paulo. And every week he would come to me and he would say, hey, let's start a company about X. And I would go, I don't know. And one day he said, let's found an entirely new database company and go after Oracle, the entire database market. And I was kind of like, okay, why? And he said, well, Flash. Flash is going to be what revolutionizes database and drives database revolution over the next 10 years. That was in about 2008, when Oracle was also starting their optimizations for Exadata, as we now know. But we saw that the algorithms that you use for Flash are just different from the relational algorithms of table scans and fixed rows. So in memory computing, and that's what a lot of NoSQL companies use, we decided to take one step further and optimize not just for in-memory with DRAM, but in-memory for Flash, because that's where you can get an extra order of magnitude of price performance. So if I say anything inappropriate, I gave this talk in Beijing yesterday, so last night. I'll flip through a couple of the slides that I think are less technical to this audience and switch over to get to some other stuff. So what we find in our market in databases is a need for databases that are running between 1 terabyte and 100 terabytes, that have between 1 billion and 5 billion rows, and the capability to So the capability to have 1 to 10 to 100 terabytes of data, but it also has to be highly available. So people running these kinds of systems still need database capabilities in terms of availability of their data and also how it's indexed. Now, where we started out as a company was to focus on key-value storage first, because that is a system and a database access pattern which, in database terms, primary key access should be super, super fast. And there's a guy named Don Hatterley, one of the guys who built DB2. He's going to be talking next month at a meetup at our place over in Mountain View about the exact idea. He said, hey, if you can get key-value storage and primary key working correctly, that's already $1 billion market. IBM does that in IMS every single year and has for the nearly 20, 30 odd years. If you can make that hardened, make that fast, provably fast, you'll be able to sell it and get it deployed in a whole bunch of different places. You will have the credibility to be able to bring to market other database concepts, be they NoSQL, document store, JSON, TrueSQL, all kinds of stuff. He said, get your storage layer modern and optimized and fast, and then move on from there. So what we did was, we took a look at the overall market. Who needs that much speed? That was sort of our first problem, because we were seeing database access times of way under a millisecond, above 100,000 and up to 1 million transactions per second per server. So 1 million per server of pure DRAM. And out of the Flash from 2 years ago, we could probably do about 100,000 per server, and scaling out linearly by just adding servers to a clustered implementation. So who needs that? The answer is the advertising business. So these are guys who are doing user profile storage, and they need to constantly be updating information and behavior that they're seeing on the internet. So this is a list of all of our customers, actually not all, a broad variety of our customers' deployments today. So what a lot of these guys are doing is they are simply keeping the user profiles. So everything that you do, that where there's an ad on the page, that ad is being bid out to a variety of companies. So sometimes it's handled by the content company, but not much anymore. It's usually getting bid out to a variety of companies. Those companies are seeing, they're bidding, they have to look up your data. Is there someone looking for you? Has Coke put an ad in front of you today? If not, then the bid from Coke goes up just a little bit, especially if it's getting to the end of the day. Are you in a particular demographic that they're looking for? The bid for you on that page may go up. There was a massive shift that occurred in advertising about 7 years ago called real-time bidding. It focused on audiences and audience reach and stopped focusing on individual pages and advertising on pages, and instead getting in front of people. In order to do that, the first part of your advertisement cycle and your ad serving cycle is to look up user data. Maybe it doesn't have any. Maybe you're in an environment, you've turned off all your cookies. Okay, that's fine. Well, maybe it knows a little bit. Maybe it knows something about your IP address recently. Maybe it doesn't. Maybe it's going to have to just blindly fill that ad. But if it does know something about you, it's very important to optimize, not show you the same ad over and over again. That's one of the most important ones. So the big data architecture that we see today looks like this. There's analytics, which is our big data. That's Hadoop, right? That's the real answer there. But what are you going to do with all of your Hadoop analysis? Well, one thing you're going to do is you're going to present it to people. You're going to have nice big screens, and you're going to use a system, or you've got Tableau or something if it's not Hadoop. But you're going to present this to decision makers and have them make long-term decisions about your different business. The other thing you can do is you can use that data in real time, like the advertising guys do. They update their models every 6 hours to 8 hours based on often 10 to 20 petabyte stores that they're using for analysis, and taking those models and putting them on the front side of their application. So that's where you need to be tracking all of the information and using the models that you're collecting and recalculating hour by hour and look at the current real-time data. So the new architectures that we're seeing, the databases that can keep up with that kind of app flow, the real-time bidding ad flow right now is probably about 700,000 per second during the strong parts of the day. That's not really peak time. That's going to be high average load. It will often peak to twice that. So you can't really do that with any of the current relational implementations without a huge amount of sharding. So you tend to see a lot of in-memory systems. Some people are getting H-based to work if you put a little bit of caching in front of it, and some of the other NoSQL systems. The app server layer, we're starting to see shifts to some of the more performant and efficient app servers such as Node and Nginx. Within analytics, besides, of course, the Q, we see a lot of vertical in our customer base and a certain amount of Netezza, Replum probably the third. And of course, a huge need for data scientists. I'm going to skip through a couple of these slides and talk a little bit more about Flash. This is the basic slide that gets everyone excited about Flash and having a Flash-based database. Okay? And in some sense, it's generic to any database that's optimized for Flash. We're just the only one we know of. So this is a sort of a cost sheet for what a 10 terabyte replicated database would look like between Flash and SSD. I'm sorry, Flash and memory. Now you notice the TPS per server, 500,000 per server. That's based on a particular Flash card. I'll talk about how we certify these things in a minute, which is the Micron P320H, which is currently beating everything on our tests. And we'll talk a little bit about why. Those individual cards will do about 150,000 per second with sub-millisecond latency. It's the only card we found that will keep latency that low at those kinds of speeds, and also with constant writing. So at those kinds of speeds, the network bottleneck takes over. And that's why RAM does not become more performant. Because you still have to get packets in and out of this thing when you're actually doing individual row access. So when the access is very row-based and you've got an application server pounding TCP for every request or whatever network you're using, it turns out Flash has just reached the point where the network is the bottleneck and storage is not. So at that point, why wouldn't you rather use the storage that's 10 times cheaper? This was an example of a case even with a smaller amount of data that I did yesterday in front of a customer. And what it came down to was with RAM, every server, the servers that they were using, 48 gig servers, were a bit smaller in price. Their SSD servers were a little more expensive. This price out is with the Intel 3700 Taylorsville drives, which are a bit less performant than those Microns, but also quite a bit cheaper for the Chinese market. And even just with a 200 gig server, I mean, I showed, this is for 10 gigs, 10 terabytes, but even with 200 gig, they still save half the price right off the bat with their first buy. And then they continue saving over and over as they expand. So the architecture that we have in Aerospike is a shared nothing architecture with direct attach. That's one of the reasons we can use Flash so well, is that if there are failures at the Flash level, people can, the system will automatically switch from server to server. And that's important because there is this myth out there that Flash is unreliable. As much as I go and I say, look, we've got 5,000 to 6,000 SSDs in use in all of our customer base, there's 10 failures, drive failures per month. People don't seem to believe that, frankly. They're used to cases where people have deployed consumer-grade SSDs, things based on Sanford's chipset, for example, that are just built to a lower standard of build, whereas the Intel systems are much more appropriate. So let me go a little bit further. So what do you have to do to optimize your database in Flash? The first thing you have to do is realize that Flash is a new beast on the block compared to any storage layer that's ever come before. Reads and writes are asymmetric. Rotational disks are essentially symmetric. Writing 4K and reading 4K are about the same speed, and it's really just the seek that you have to worry about, right? RAM is the same thing. Reading 4K and writing 4K are about the same speed. You don't have to worry about the seek. The real difference with Flash is large blocks, and doing large block optimization for your writes is the most important thing you can do. Now, firmware will eventually catch up, right? Eventually, the firmware will get good enough that database companies will be able to do small block writes and not have the crushing performance penalties today. What happens today is if you write even in 4K blocks or less, you end up having these terrible, essentially garbage collection pauses within the hardware layer that really disrupt the smooth operation of the database. So that was, I would say, the primary optimization we found to be so important was keeping your indexes in DRAM, because RAM is still cheap, by today's standards. Keep your indexes there, and then use the storage in SSD. That's really the bulk of your memory anyway. The other benefit is that kind of large block access pattern is well known to database developers. That's called a log-based file system. And log-based file systems are great for MVCC if you're any database people here? No, talking about it, okay. NeoSoft people? Okay. Anyway, being able to write those large block files, that's common to database people, and it's actually a fine way to think of things, instead of having to write in place.
Excuse me.
Yes?
What's the significance of that log stick that you said, random distribution?
Okay, so most people these days think they should be using RAID. Instead, what we have is essentially RAID at the server level, one level. So since we're already doing 2 copies of the data for high availability, we need the indexes to be able to take over immediately. And we need the kind of predictable performance that comes with not using a RAID card. Maybe the RAID guys will work. Any RAID guys here? Half the RAID, one in the back. So we're having terrible problems with RAID cards and SSDs. The best thing we can find right now is, I think, the Dell H710P. I can't remember the model number of the LSI chip. Basically, LSI's clones, because that thing bottlenecks about 4 SATA drives. And yet I can put 20 SATA drives in the chassis right now. And I could get 5 times more performance, except the RAID cards are, and that's even without even doing anything like RAID and actually dealing with stripe sizes. We're already managing for the stripe sizes of SSDs. We're doing block writes according to the right size, the chip layout already. So get RAID out of the way, as I was saying. Does that make sense?
Yep.
So one thing that we did was, by the way, this is a good statistic. So if you look, there's a public number, the amount of money that Facebook and Apple put into SSDs, right? So the big guys have already figured out that SSDs have changed the world, right? So one thing I tell people is, if you're competing with Apple or Facebook in the world of social or anything else, and you're not using SSDs, you are at a massive disadvantage. You can't store the amount of data, you can't find it as quickly. So one thing that we do is we have a certification tool. Because the use of the database for Flash, now that I know there's a lot of hardware guys here, it doesn't come out according to a lot of the standard benchmarks. Because a database where you're not writing to it is an empty database. I know how to return 0, key not found. A database that's not taking reads is also pretty dull. So you have to think that there's going to be a fairly heavy read and write load in parallel. And what do writes do in parallel to latency of reads at the same time? That's one of the tricks of SSDs and one of the optimization points of a lot of vendors. So what our tool does, which is available on GitHub at Aerospike ACT, is it applies read and write patterns in parallel and then measures read latency. Because read latency is one of the most important factors to having a fast database. So this is our current winner. And you who's building a new flash device, feel free to send me samples. I got an update from Micron with their newest product this morning. So it's a little hard to read, but this is a histogram of hour-by-hour performance. And what it means is only 0.2% are above 1 millisecond during that hour. And the load here that it's running is 150,000 read IOPS while still sustaining over 200 megabytes of writes. And that's a number that we find pretty impressive. So same numbers for some of the other drives that we like a lot these days. The Intel S3700s, just doing 6K, or the other one was 150, is showing 1 full percent over a millisecond. And even worse, when you start seeing drives with numbers where they've got pauses out in the 8 millisecond area. And those Fusion IO drives are pretty good. This is where we were in the previous generation. So the good news is the flash guys are moving forward really fast. And as a database guy, I love that. The Intel X25s were pretty much the first drives out there. And they suffered for, even just at, 2,000 reads per second with the same amount of writes in large blocks, 20% of reads were above 1 millisecond. So that was why we had to go out and actually build this tool. Some of these drives, it's actually worse than what we see here. For example, this Micron drive, this number out here of 1 millisecond, 1%, nearly 1% at 64 milliseconds per read was a serious problem. And it only cropped up after 36 hours of testing. So in the first 36 hours of testing, the drive was great. It was one of the fastest we saw. And it hit this cliff at 36 hours. Those guys have really nailed whatever that problem is in their controller firmware, because now they're showing up as one of the fastest in the style of test. So, some other numbers here. You can also see what some of the Sandforce-based machines are doing also with some of their older devices. We still find them to be not all that great. Yes?
Do you know the fundamental mechanism why is 64 milliseconds?
Yes, I do. But I don't want to put them on the spot. I mean, poor guys, they wrote some bad code.
I see, okay. This is nothing to do with the hardware or whatever. It's there.
Well, it sort of has to do with the hardware, because you've got interlocks, because every device has a problem where there's a physical to logical translation to it, right? Because you've got basically all the sectors you're writing to, and then you've got all of the actual blocks of memory, right? You're constantly sort of shifting this around as a firmware vendor. You often have 2 layers of these things. And sometimes you have to do garbage collection. And it is a common bug, it was a common bug back then, it seems like people have nailed it pretty much now, where you would lock that entire table while you're trying to reorganize your memory. And if you do that, you shouldn't be locking against reads, but maybe you screwed up when you started locking against reads. So that's not to knock too much on Micron, but that's essentially why a lot of those numbers were high, was during those write cycles, they were eventually getting to a point where they had to reorganize their memory, and they weren't being hyper-intelligent about it. The good news is a lot of that is behind us, and the top flash vendors that we are seeing, notably Micron and Intel to some extent, Biolin and Fusion, have largely moved that to different extents and are addressing it to a great extent. So one thing I would leave you with is, first of all, as a database guy, this is an extraordinarily exciting time to be thinking about new databases. I'm expecting over the next year, it might be a year, might be 18 months, the price per byte of flash is going to drop below rotational drives. I think it's pretty clear that it's going to happen. Exactly when, 18 months, 2 years, hard to say. These kinds of performance problems that we see are getting licked. And being able to have flash optimized databases is really creating interesting opportunities for social networking companies that are doing broader levels of analysis, especially in real time. So, thank you.